Good evening. Good evening, friends. We will get started. Okay. Any questions before we begin? Yes, no, maybe. Okay. So that means no question. Okay, I'm going to share my screen now. Thank you so much, Veerbhadra. I'm really sorry, guys. Okay, I was on mute. Um, thanks for telling. So see, we're talking about, okay, let me start again. Okay, so today we'll talk about threading, okay, multi-threading. So multi-threading, which I was saying is, it's like running multiple codes in parallel. Okay, it's like, so I was giving an example of a game. When you're developing a game, like say boxing game, okay, two people, they try to hit each other, isn't it? So now these two people will try to hit each other in parallel fashion. You can't have sequential, that one person hits, then second person, then first person, then second person. Then it's not a game, isn't it? So we create multiple thread, and each thread is like running in parallel. Okay, so to do that, we need to import threading. Okay, we'll import threading, and from threading we have thread using which we can create a child thread. Okay. Okay, so let's say let me define a function. This function will be executed by a thread. Okay, so I'm going to say def say thread function. Okay, and here I'm going to run a loop. Okay, so for I in range, say 5. Okay, and you say print child thread has now started, or something like this. Okay, so this is a simple function, and now I'm going to create my thread T1. So T1 equal to threading dot thread. Okay, and we'll give a target. What is the target? Target is, what should it do, right? What should it do? So I'm saying it should run the thread function. So I'm going to say thread function. Okay, you have to pass it like a variable. So I've removed the bracket open and close. Okay, so this is T1. Now we have to call it. So when you say T1 dot start, that's when thread 1 will start. Okay, so see, thread is called. Okay, okay, so you have this. Now what I'll do is, I'm going to maybe give some sleep here. Okay, I'm going to say import time. Okay, we'll purposely give a in for loop itself. Okay, I'm going to give sleep for 1 second. Okay, so I'm going to say time dot sleep and 1. Okay, so it says child thread has started, sleep for 1 second. Again, child thread has started, sleep for 1 second, child thread has started. Okay, so when I run it, you see, okay, there is a gap of 1 second between each output. Okay, now I will create another function. Okay, I'll call another function. So child thread 2. Okay, this is child thread 2, and I'll say second child thread has now started. Okay, and I've given time for 1 second. Now I'm going to call T2, another thread. So I'm going to call another thread T2. Okay, and here I'm going to say thread function 2. Okay, now I will start T2. T2 dot start. Okay, now when you run it, you see child thread has now started, second child thread has started. Okay, second child thread has started, child thread has started, child thread has started. Okay, both of these threads are running in parallel together. See, I'm not saying, see, T1 dot start doesn't mean that it will execute first T1 completely, then it will do T2 completely. Okay, this would have been the case in the normal programming, but in threading we are able to run two different functions parallelly. Okay, This is the beauty of threading. Now you can extend this, okay, concept. Okay, so okay, now there's one more option here called as join. Okay, so when I say T1 dot start, T2 dot start, they got started. Okay, but I can say T1 dot join. Now I want, okay, T1 to join, and then I want T2 to all join. Okay, now T2 will also join. Okay, now let's run it and see the difference. Right? Okay, join means, we are saying these two threads should start at the same time. Okay, now you run it again. Okay, okay, you see this second child thread has now started, child thread now started. It got printed at the same time. It's not printing in different line, it has got printed in the same time. Okay, so this is how you would run a multi-thread program. You're running multi-thread together. Okay, now we will talk about let's say a critical section. Okay, what is critical section? Okay, now let's say, see here we are printing, we have two different function for two different thread. Okay, two different function, two different thread. I can even say T3. Okay, I can even say T3, and T3 will run say function 2 itself, right? So I'm going to say T3 dot start and T3 dot join. Okay, so now, okay, you would get it in that fashion. Okay, absolutely no problem here, isn't it? Now the problem comes when, okay, see here we are just printing, so it doesn't matter who prints first, but problem comes when you want to edit a file. Okay, okay, so let's say you have a text file and you want these threads to edit the text file. Now when, let's say, we are running three threads, and first thread gets access to the file. Okay, first thread gets access to the file. Okay, okay, good, then it goes and starts editing. But while it is still editing, okay, the editing is not complete, your T2 has gone and also is trying to edit the same file. He's also trying to edit the same file. That's when the problem comes. Okay, so the information that you're going to see if they're reading the file, then it's not a problem, right? But if they're trying to write, then it's a problem, right? Because only one person or only one thread can write at a time. Okay, so critical section which is, it's like a resources which is being shared. Okay, now if the thread comes one by one, doesn't have any problem, but if two threads come together at the same time, then what do we do, right? So for example, you want to write a file using one thread, and second thread also has come before you finish writing. How do we handle it? Okay, so there is concept called lock. So this is called critical section. So critical section is a section or piece of code or resources which both thread is trying to access. Okay, but only one can have access to it. Okay, so we create what is called as lock in such case. So okay, so let's say two threads are there, whichever reaches first to the resource, saying I have reached here first, so I'll have access, it will apply a lock. Lock means Once lock is there, the other thread cannot proceed. The other thread will wait, will have to wait. Okay, the thread which has reached their second, okay, will have to wait for the first thread to complete. Now, since second thread has come, so second thread will be ahead in queue. Let's say thread 3 also comes there. So thread 2 and 3 is waiting. Once thread 1 is done, okay, so you acquire the lock before you start doing the work. You acquire the lock. Once you are done with the work, you will release the lock. So we acquire the lock and we will release the lock. Okay, and then, okay, when it's done, then the thread 2 will come. Right? Thread 2 will come. Now thread 2 will acquire the lock, perform the operation. Okay, thread 3 is still waiting. Okay, and when thread 2 is done, then thread 3 will come, acquire the lock, perform, and then exit. Okay, will then release the lock. Okay, so let's see that example. This is a sample example where we created 3 threads. I'm going to move this to another location. Now I'm going to talk about okay, we'll talk about accessing critical section by acquiring and releasing the lock. Okay, okay. So of course, for doing threading, you have to use threading. Okay, I'm going to create a global variable X. Okay, so I'm going to call global variable here. Let's say X equal to 0. Okay, and we'll write one task. We'll write one function, sample function. Okay, in this increment. Okay, in this we will try to increase the value of global X. Right. So I want to use X. I can say X equal to X plus 1, or to indicate that you want to use global X, you can say global X, and then here I'm going to say X plus equal to 1. Simple function which takes the global value and increments it, isn't it? Okay. Now I'm going to create another function. Okay, so here I'm going to say perform task or something like this. Okay, perform task, and I'm going to increment the value of X to a large value. Okay, to a large, so that you can actually see the thread which gets access to perform task has to wait, isn't it? So if you perform smaller task, then things will become faster, right? You will not be able to see the deadlock situation, right? So we will create a task, okay, and which will give a bigger task, so that first thread which comes to it will have access, and second thread which is behind, okay, will have to wait, right? Okay, so with that concept, okay, let me create, okay, so let me create this, okay, perform task, and I'm just thinking what to do. So I'm going to add here for, not here, sorry, in perform task, I'm going to say for I in range, okay, maybe 99,000. So I'm purposely running this 99,000, okay, and I'm going to call increment. 99,000 means it'll take long time to run the increment, right? So while it is doing so, the log 2 will come back, isn't it? Now I'm going to say, okay, so this task is done. This is the critical section. Perform task has become critical section for us. Okay, this has become critical section for us. So I'm going to say def main task. I'm going to call all these functions from here, main task. Okay, and in this again I will use the global value. Okay, global x, and I'm going to reset the value of x to 0 here. Okay, I'm going to reset the value of x to 0. Okay, so I have a function increment which increases the value by 1. Okay, then I have a function which will call that increment, and it is going to call many times. Okay, just to delay the process, and this becomes a critical section for us because many thread will try to access this. Okay, and in the main I'm resetting it x to 0. Okay, so now I'm going to create 3 tasks. Okay, so I'm going to say T1 equal to threading dot thread, and we will say target equal to perform task. Perfect. Now I'm going to create 3 or 4 maybe. Okay, so we'll create 1, 2, 3, 4. Okay, 4 threads. I've created 4 threads. Okay, now we will start the thread. Okay, I'm going to start the thread. Okay, now in starting the thread, I'm going to say T1 dot start, T2 dot start, T3 dot start, T4 dot start. Okay, so I've created 4 threads. Now I'll say thread join. Okay, wait until threads are done executing. Okay, so I'm going to say T1 dot start, T2 dot start, T3 dot start, and T4 dot start. Oh, sorry, start is already done, right? Where should we join? Right, I'm joining them. Okay, great. Now I want to execute this. I want to execute the main task, right? So I'm going to say for I in range. Okay, I in range. I'm going to do 15 times, let's say. So range 15. Okay, main task. So main task will run 15 times, right? Main task is creating 4 different thread, and it itself is running. Okay, 15 times. Now let's run this and see what happens. Okay, so we'll do one thing. We are not printing anything, right? So that's why we were not sure. We don't see anything, correct? So I will add some print command here. I'm going to say print. Okay, iteration. Okay, and iteration. Okay, equal to x equal to, okay, we'll put the x value. Okay, x equal to x, and here I'm going to put I plus 1. Okay, so I will be first, right? When you say 0, we should say first. When iteration is 1, what is the x value, right? So on. You say this iteration 1, 2, okay, you are getting 39,000, okay. So maybe I need to make it even more big. So see, it is waiting, critical section. Iteration 1 has got access to it. So others were waiting. Okay. Now you have your other task. Okay. Others are waiting. Okay. So here this has access to it, right? But we haven't added log. Okay. So here to perform the log, okay, let it run. This is the main function, right? You want, okay, one of these thread to access this, right? Now, what I'm thinking is, okay, okay, let it run 15 times. Okay, done. Okay, so I'm going to add a lock here in the main. Okay, so threading has threading dot lock. Okay, so before we start creating thread, I'm going to say lock equal to, okay, threading dot lock. Okay, so I've created this lock object. Now where do we add the lock? Lock should be acquired before you call increment and released after you call increment, right? So I'm going to say lock dot acquire. Okay, this is a definition here, isn't it? Okay, inside the definition. Okay, now how do we pass this? We have to pass this lock, isn't it? So I need to pass arguments to this perform task. Okay, so here we will say lock. Okay, so log that we created in main task, we need to pass that log, isn't it? So you get log dot acquire here and log dot release here. Okay, but how do we pass this argument here? So we have a command called as args. Args stands for arguments, and here you say, okay, log. Since it's a tuple, so when you have one value in the tuple, we have to say value comma, isn't it? That's what we saw. Okay, when you have no argument in tuple, then bracket, empty bracket is fine. When you have two or more, you can say value comma, right? But then if you have only one value, you have to say, okay, you have to say, value one comma, okay? So I'm going to add this to all the 4 threads that I have created, okay? Okay, so maybe what I'll do is, this is too much. So let me delete and do with lesser value. Okay. Okay. Even better would be if I say range 15. Okay. And we will say here time dot sleep. 1 second. Okay. Import. Okay. So it is waiting. Okay. It is running, isn't it? So 15 seconds it will wait because we have range 15. Okay. Now instead, if I don't give lock, still getting executed line by line. Right? If I say I wanted to see the output here. Okay, now you got increment 1. Okay, so you are able to get this. Okay, X value. Okay, maybe this is too much. Maybe you can do 5 here, then it will be better. Just to, it shouldn't be too slow also, right? Okay, so X1 is 20, 20, so on. And if you want to apply the lock, you say lock.acquire and lock.release. That's it. So now you have control over your critical section. Critical section is that function increment, and when you say apply lock, other function, other thread will not go. It will wait for you to finish it. Okay, whichever thread reaches first, that will have access, and you have no other option. Other thread will have no other option but to wait in the sequential manner. Okay. Once they are done, when the lock is released, that's when the other thread can enter. Okay, this is how threading works. It has multiple uses. Okay, the distributed systems, the game development. Okay, they all use clustering. Okay, sorry, not clustering. The threading. Okay, the advantage of this is that you can run multiple things in parallel. You can write 2 different functions and create 2 different threads to execute each of those functions. So what happens, it will appear as if the 2 functions are executed at the same time, not one by one. Okay, so okay, we'll stop here today. Okay. This is the concept of thread. Okay, we'll stop here for today. It was a small concept, but good concept. Okay, you will know how to run things in parallel. Okay, you can write 2 different functions and then launch the thread. Okay, and pass the function name to the thread. So thread will go and execute that. Okay. Second thing, what we have said is you have to, uh, you know, you sometimes can run See, modern systems have been designed to handle deadlock kind of situation, okay, or the error kind of situation where you want to read a data, but data is being modified. So if the lock is not there, you will not see a consistent data. Sometimes you will see 3, sometimes you will see 4 because people is using editing in the background, okay, and it is playing. That should not be the case, right? Only when user says, yes, I'm done with the changing, okay, then only it should get reflected in the database. So that's what generally happens. There's a log that is associated when you want to make anything changes. So you apply a log. When apply log is there, then nobody else will see the value. Once you are done, then you release your log, and then everybody will be able to see the value. Okay, you don't want people to read the inconsistent or the incorrect data. Okay, that's the purpose of your log. Okay, we'll stop here, guys, for today. Okay, if there are no questions, please practice this training, and we'll see you on Monday with new topic. Okay, we will try to complete as much as possible next week, and we will meet on Monday just to clear any doubts that you might have. Okay, and towards the end, we'll also give you introduction about machine learning, data science is all about. Okay, so next week we'll also meet following week, but okay, we'll complete most of the syllabus by next week. So if you have any questions and when you're practicing or getting doubt, please let us know. You can post it in the YouTube, you can post it in the website that I'm talking about, or you can tell me in the chat when we meet in the next class. Okay, so great. So let's end it here. You have a good Saturday, everyone. Good Saturday. Enjoy your weekend, enjoy your Sunday, but do practice, and catch you on Monday. Take care. Bye.